Okay, good evening, ladies and gentlemen. I'm Daniel Chan, one of the subject lecturers responsible for this subject, BRE 42A1, Construction Engine Management. And I think, okay, again, welcome you back to school after the unexpectedly long holiday of Christmas holiday as well as New Year holiday. Because of the prevailing coronavirus invasion situation in Hong Kong as well as worldwide, there's no way except we need to conduct the online lectures and tutorial through this Blackboard Collaborate Ultra tool. Okay, it's also a new technique to me to teach online rather than face-to-face. And I understand that this subject is a compulsory subject for all BM students, including a part-time BM student. So, so tonight I'm going to share with you a few things. The first one is about a brief introduction about the subject online. And the second one is the first lecture topic on construction productivity, and followed by I'm also going to share with you the lecture tutorial schedule arrangement with you very soon regarding this subject. Okay, all of you can hear me and see my face. Okay, so if you have any problems, please feel free to raise your hand or type in something in the chat room so that I know your problems. Okay, first of all, I would like to share some of the basic information about this subject to you first. Okay, again, I think we have seen each other from other subjects before, especially the subject research methods or core analytical skills and method in your year 1 study or year 2 study. Okay, dating back 2 to 3 years ago. Okay, so I will see. I'm seeing you again on this subject. I'm Daniel Chan. In case you've already forgotten me, I'm Daniel Chan, an associate professor in construction project management, and I was the former associate head of department responsible for teaching, and currently I'm the chairman of BRE undergraduate program committee, responsible for all the undergraduate programs as well as our high diploma programs. I'm a project manager and construction manager by profession, a charter building engineer in the UK, charter building professional in Australia, and charter a registered construction manager based in Hong Kong. And my research, apart from multi, my research areas fall in this area: consumer time performance, construction procurement system, relational and collaborative contracting, partnering and licensing, high cost contracting, NEC contract, PPP, safety management, and more recently on BIM and sustainability practices. I was also conferred many awards at departmental level, just like a program management at faculty level as well. I also published 2 scholarly textbooks based on my research findings. One of them is Relational Contracting for Construction Excellency, Principles, Practices, and Case Studies. 3 years ago, I published another one, High Cost Contracting Strategy in Construction, Principles, Practices, and Case Studies. Okay, more recently, just last year, okay, I was selected as the winner of BRE Departmental Award for Outstanding Teacher 2018 to 19. Okay, and I just received this award in early October last year, and initially, okay, I will receive the award at the congregation tentatively held on 12th of November last year. But because of the social movement at that time, so our congregation graduation ceremony has been postponed until further notice. But anyway, thank you for all your support to my subjects to give the SFQ score, as well as a lot of letters of appreciation or thanks from different students, including you guys here. Raise a very brief introduction about myself to you. Okay, now I would like to give a very brief introduction to this subject before actually kicking start the first lecture topic. Again, I'm Daniel Chen, and this slide shows my contact details. In case you encounter anything related to the subject, you are welcome to contact me through all these means. This subject, BRE 4281, is a compulsory core subject for all the BEM Year 4 students, including full-time mode and part-time mode, you guys here. And the prerequisite of this subject is BRE 350, Project Management and Procurement. That means you must pass this subject before taking BRE 4281. It carries 3 credit units similar to other subjects. And I'm Daniel Chen, the subject leader of this subject, and followed up by another subject lecturer, Dr. N.U. This subject was decided to develop the skills and capability of students to apply decision-making theories and operational research techniques in managing your construction projects. Apart from the subject aim, we also put forward 3 different intended learning outcomes. That means by the end of the subject, you will be able to achieve all this. First one, try to identify those management problems in different areas, including construction engineering activities, management practices, human resources, plant management, as well as operation and strategic management. After identifying the problems, you may put your problems into some kind of analytical models for analysis. Then, based on the results of the analysis, you can make your decisions and make your recommendations, solutions, based on the results obtained from those operational research techniques in order to get the best optimal results for implementation. So by the end of this subject, you should be able to achieve all these learning outcomes yourself. You also come up with around 10 lecture topics for this subject, including construction productivity measurement, part 1 and part 2, that I'm going to share with you tonight. After that, I will start to share with you some of the common operational research techniques that you can use in order to find out the best solutions for you, including decision theory and application, inventory control theory, as well as Monte Carlo simulation. Okay, we try to play around with probability and statistics under those theories. Last but not least, I will also share with you how to achieve fast-track construction from technology point of view and from management point of view. In the past, in order to achieve fast-track construction, we will make a large scale of prefabricated structural elements like precast facades, Picard staircase, Picard beams, and Picard kitchen, especially to those public housing projects. More recently, the CIC Construction Industry Council tried make a big push in using MIC, modular integrated construction methods, in order to develop those prefabricated units put on top one by one to the building, in order to achieve fast-track construction by using those new technology. So I will go through all these topics with you during the first half of the subject. After that, Dr. NU will take over the rest of the subject. She's going to share with you some other topics related to construction engineering management, just like risk management, value management. Another operational research technique is linear programming, green labeling scheme for construction materials. Nowadays, we want to use more environmental friendly and greener materials to construct our buildings. So it's a very new knowledge that you should know as a building engineering student. Last but not least, she's going to share with you some basic concepts, operations of construction management practices in mainland China. Okay, in terms of teaching and learning approach, usually we will have, for part-time student, usually we have 3 hours per night. Usually we have 2 hours for the lecture plus 1 hour for the tutorial. In the lectures, we try to present to you some basic concepts and principles of different topical areas that I just mentioned. Apart from lectures, we are going to have some small group tutorial sessions, so that in the tutorial classes, you'll be given some in-class problem-based assignments to work with in order to test your understanding, applications of those concepts in real life, and also some discussion topic, problem solving, and group presentation. And the detailed arrangement of the tutorial will be briefed by the subject tutor during the first tutorial class of each next week. Apart from those lectures and tutorials, you may also need to have some kind of self-study yourself by looking at those recommended references already included at the end of each lecture PowerPoint file, and also included in the subject description form for your self-study and self-learning. Assessment method, this subject, group coursework will contribute to 50%, and the rest will focus on the individual coursework written examination, lasting for 2 hours. And the total coursework mark for this subject will comprise of your verbal presentation, your group report, as well as individual tutorial participation. Okay, try your best to attend the lectures as well as the tutorials as far as possible. You will also be given some in-class problem-based assignments, although those in-class exercises will not be assessed. That means you just do it yourself, no need to submit at the end of each tutorial, just in-class exercise. They will be used to test your basic understanding of the knowledge, concepts, and applications of those operational research techniques, which can be applied to construction projects in order to find out the best solutions for implementation. Again, you strongly recommend to refer to those recommended references already included in the subject description form, as well as at the end of each PowerPoint file for self-learning. Okay, most of the subject material already uploaded to the Learn at PolyU Blackboard website. You may just simply go to this web link URL, log in with your student ID and password. Those essential information already marked up there, like the subject description form, lecture and tutorial schedule, subject introduction that I'm sharing with you right now, corresponding lecture notes, and associated in-class tutorial exercise for you to work with. The questions and guidelines for seminar presentation, very detailed, already marked up there. Last but not least, there should be some standard evaluation form for verbal presentation and written report, including the guidelines, the assessment criteria, as well as the assessment rubrics before your verbal presentation and submission of your written report, so that you can see how you are going to be assessed in the verbal presentation as well as the written report. Okay, that's a very brief introduction about the subject. Okay, any problem so far? Okay, student, is it clear? Can you follow me? Okay, good. I just remembered that you have already finished your capstone project, BRE 466, in last semester 1. So this semester would be your final semester before graduation, including this subject. Okay, thank you for your responses. Okay, I saw quite a number of students joining in after work. Welcome again to this subject, just to catch up. Okay, okay, let's kickstart our first lecture topic tonight on construction productivity. Okay, so before I start, I just want to share with you some of the track record in the world in terms of high-rise construction. This project is called Burj Dubai, or Burj Dubai Tower. It was claimed as the tallest building in the world back in 2010. Okay, it has the floor height of 8 to 8 meter and also 160 number of floors. And it took 6 years for completion, and the total built-up area is equal to 5.67 million square feet. Very, very large. Okay, that is the outlook of this building. Very sophisticated design. Okay, very high. This building also had its grand opening in January 2010. Okay, before going on, I would like to show you this short video, okay, regarding its grand opening here. Can you see the video and hear the voice there? Oh, good. Okay, just enjoy for a few minutes. Okay, let me stop the video because of the time, and going back to okay, you can imagine, right? You can build anything you like, provided that you have money in hand, just like Dubai, because they have petroleum. This is another track record of 10 tallest building in the world back in 2010, some 10 years ago. The highest building nowadays is still a Burj Dubai Tower, followed by a Taipei 101, 508 meters. In Hong Kong, we also have a high-rise building like International Commerce Center (ICC), followed by Petronas Twin Tower, located in Kuala Lumpur, Malaysia. How about in mainland China? In mainland China, we have also another more high-rise building, Shanghai Tower, located in Pudong, Shanghai. It was claimed as the second tallest building in the world upon completion in 2015, and was claimed as the tallest building in mainland China. Okay, and it has height equal to 632 meter. Nothing is impossible, again, if you have money in hand. There will be even higher building called Kingdom Tower in Jeddah, Saudi Arabia. This building will be the tallest building in the world upon completion in 2021. It has 167 floors, and the building height just over 1 kilometer. Wow, very, very high, over 1 kilometer. It will take around 9 years to complete, and it's going to have the planned grand opening in 2022, 2 years later from now. Please watch out. How about in Hong Kong? In Hong Kong, we also have some high-rise building record like this. Okay, like IFC2, double 8 story high, and also one ICC 118 story high, just located in West Kowloon. If you are standing at the podium level of our university, you can also see this high-rise building yourself. Okay, let's formally kickstart the lecture today. It's called construction productivity measurement. Okay, construction productivity measurement. There's some photo for you to think about. For example, this is the typical concreting operation. We try to pour the concrete inside the column formwork. You may ask, how long will it take to complete this operation? 5 minutes, 7 minutes, or 10 minutes? You may need to do some site observations in order to find out the results. How about the second one? How long will it take for the concreter to pour out all this concrete to this 4 area of concrete? Okay, 4 slab. How long will it take by using concrete pumping method? Or in terms of tower crane, what is the utilization level of the tower crane? Okay, is it 70% utilized, 80% utilized, or 100% utilized? Okay, by using different productivity methods, we can find out all these answers ourselves. Okay, so the topics that I'm going to share with you under this area is what is production and productivity by definition, and what are the common productivity techniques that we can use, including work study. Under work study, we may have a method study and work measurement. Work measurement techniques will mainly consist of continuous time study as well as activity sampling or work sampling methods. Last but not least, I'm going to share with you some of the essential factors which will affect construction productivity, sought from different literature review. Okay, first of all, what is production by definition? Production is simply a process, okay, conversion process. We try to convert the inputs, just like labor, material, components, capitals. Convert all these inputs into some kind of outputs, like our final products. The final products usually adds value. That means the total output will be more valuable than the sum of the individual inputs. Just like under synergy theory, 1 + 1 is larger than 2. Okay? Because the final products will be more useful. Or you can use this diagram to show the relationship. Okay? Inputs can be labor, materials, components, or capitals. Okay? Then what are common labor in construction projects? Okay? The labor can be concreters, 石屎工人 ，OK， timber formwork erector， 板模師傅，同埋呢個嘅steel bar fixers or benders，OK， 紮鐵師傅啦、石屎師傅啦，同埋呢個特板模嘅師傅 ，OK，those are the 3 main types of labor working for your project. How about materials? Material may consist of timber, steel reinforcement, as well as concrete. Without these materials, you can't construct your buildings. Okay. Of course, capital is also important. Without capitals, without money, you can do nothing. Okay. Another input may be plant and equipment. Okay. You need tower cranes, you need excavators, you need a lot of machinery to help you to do those heavy work. Then we try to convert all these inputs through the production process and then generate outputs. Usually the final product are our constructed buildings. Usually buildings that you can move in to live and to work. Okay, what is production function? Production function is we try to relate the outputs to the inputs through a mathematical relationship. Okay, mathematically, output is equal to a function of land, labor, materials, and capitals. And the outcome of production process is usually affected by both factors. One may be technological factors. For example, we can use higher power productive machinery to help us, or we can also provide some come up with some human factors, social factors, in order to motivate the workers to do faster and harder. Investment in education and training so that the skills of the labor can be enhanced, or increase the labor motivation. If you can achieve a higher productivity level, you can earn more. Okay, or we can also provide year-end bonus. Okay, if the workers is well performed, okay, then we can give them year-end bonus as a kind of appreciation and motivation. Again, output can be interpreted as the ratio of outputs to inputs mathematically. Okay, conceptually, this equation is correct, but in real life, it may be difficult to find out. Okay, because the inputs from different resources may be measured in different units. It's difficult to combine them into one single measure in real life. Again, productivity is equal to output to the ratio of inputs. The inputs can be labor, materials, plant and equipment, labor, capital, energy, and all these. Okay, so in principle, we try to fully utilize our construction resources, including labor, plant and equipment, and material as far as possible, so that we can complete our project with the least possible time and the lower cost. But in real life, it's difficult to achieve. This ideal case will not be achieved in real life. In order to improve the productivity, we can enhance the productivity without major expenditure on new resources. For example, the counting process. We can redesign the counting process in order to have a more smooth concrete delivery from concrete batching plants to your site. Okay, we need to carefully design the whole concreting delivery process step by step, so that you can have a smooth supply of material to your site without any interruption. Or we can also invest some money in the resources in order to enhance the productivity. For example, we can make use of the high efficient machinery or higher power concrete pump with higher pumping rates. Okay, if we can make use of a higher concrete pump, you can pump the concrete faster, so that the productivity can also be higher. Okay, after giving you some basic concepts regarding productivity, let's look at some of the methods that and how we can measure the productivity level. Work study. Okay, according to British Standard 3138, work study is a kind of technique including method study and work measurement, and we try to examine all the human work holistically as a whole, and then systematically investigate all the resources and factors which will affect the efficiency and economy of the situation under review, in order to make some improvements. This is a very comprehensive definition about work study. And work study, the concept of work study was developed in early 20th century for us to investigate, analyze, and improve the plant utilization levels and site productivity levels altogether. Under work study, we can have a method study or work measurements. Method study means we try to look at the whole production process to see what happened. Is there any problems in the production process? If there are, try to identify the problem first and then make some improvement. Okay, method study means we try to look at the method of production, the production process itself. For work measurement, it means that we try to find out the standard duration for a normal worker to compete. That means we want to establish the standard for control and comparison. That means for a normal worker, if we have that scale of work to be done, then how long will it take for a normal worker to compete? We want to set the standard duration to complete all this work. Okay, by using several productivity techniques, it can give you higher productivity from different perspectives. To the employer, if we can achieve higher productivity, that means the cost will be lower, and by having lower cost, that means we can have higher profits. To the workers, if they can achieve higher productivity levels, they can earn more higher salary and better job employment terms and conditions and promotions. For application, we try to establish a standard for us to follow. For example, how much does it cost per meter cube of concrete paste in order to set the piecework weight and incentive schemes. That means we need to set the standard, okay, not too high and not too low, in order to benchmark the performance or the productivity level of different workers. Okay, apart from work study, under work study, we have a method called method study. Again, according to British standard, we try to systematically record and critically examine all the major factors and resources in the existing production process and the proposed or revised method of production, okay, in order to find out the easier and more effective methods for production, okay, for the production process, and try to reduce the cost. Again, it's a very comprehensive definition about method study, and we also want to try method study can also be regarded as a kind of process observations, because we look at the process one by one along the whole production process to see whether the production line is smooth or not, problem-free or not. Method study, how to apply method study in real life. First of all, we try to classify, select, those operations under study that we will be interested to look at, and then try to record all the basic procedures along the production process, and then try to critically examine and analyze the production methods stage by stage. If we identify some problems, we may need to come up with some alternative, and then try to apply the alternative for implementation. Okay, under how can we apply the method study in real life? First of all the resources we should look at all the resources involved, including labor, material, and plant under method study. We also need to look at the site layout plan, material flow should also be included under investigation. And usually, we try to look at those activities which will be repetitive in nature. For example, the floor cycle times. You can imagine, right? For a typical building, if the floor cycle times can be reduced by 1 day, that means the whole superstructure can be reduced by 2 or 3 months, for example. If that is the case, the whole project will also be completed earlier by a few months. Okay, so usually we'll focus our attention to those activities which will be repeated many times in your project, just like floor cycle times. Okay, so in real life, how can we implement the method study? Actually, okay, there are 5 major steps that you may follow. The first one is record. Okay, after identifying your operation, we try to look at those key activities of the production process in more detail by using some graphical methods, usually pie chart or flow chart. Okay, try to list out the main activities step by step, logically. Then examine. We try to critically examine and analyze those activities and try to identify any problems in some activities. Okay. After identifying the problems, we may need to provide some alternative or solutions for implementation. Then we can develop the best method or alternative for implementation in that activity, and then try to install that new method for implementation under supervision of supervisors and operators. Okay. At the end of the day, if you find out that the new method of production is good enough, effective enough, then we can keep installing that new method for implementation if it's good enough. Otherwise, we may need to come up with another method and then implement into and inject in the production process to rerun the process again. Okay, until we find out a certain method which can improve the production process or improve the productivity. Then we can just keep it there for future implementation. So under method study, we have these five stages: record, examine, develop, install, and maintain. Okay, under what conditions we should implement method study? Okay, this is usually all those situations, circumstances listed here are quite negative, unfavorable, that we may consider using method study. For example, is there any bottlenecks in material flow? That means non-continuous concrete supply from batching plants to your site. Okay, try to see whether you have a smooth concrete supply process between the batching plant and to your concerned sites. Okay, you want to have something smooth. Or you may encounter some double handling of materials, idling plant or equipment. That means the machinery is always stopped there, doing nothing. Okay, or the workers always standing there without doing things. They may be waiting for something. Okay, so that we need to find out the reason why they are always idling. Or your site may have a lot of accidents. Then you may need to find out is there any problems on the safety and health measures, not sufficient or not effective, that we need to find out. Or you may encounter a high sickness level, maybe due to poor air ventilation, frequent machinery breakdowns. Then we need to find out the reason why in order to make some improvement. Poor quality products, excessive overtime, or high material wastage. For high material wastage, that means there may be some problem in the production process, which will affect your quality, and there may be a lot of material treated as waste, okay, not up to standard. Then there should be some problem in the production process that we need to find out. Okay, if you encounter all these unfavorable situations, then you may consider using method study to find out problems and then make corresponding improvement accordingly. Okay, apart from method study, we have also work measurement. Again, according to British standard, work measurement, we try to use work measurement techniques in order to find out the time for a qualified worker to carry out a particular job at defined level of performance. Usually, for a certain operation, we may need to break down the operation into some kind of typical activities or sub-activities for us to investigate. And the main function of using work measurement techniques is we try to set the standards for control and comparisons. Okay, work measurement means we try to estimate how long will it take for a normal worker to complete a particular task, 3 days, 5 days, or 7 days. By having by setting this standard, just like a ruler for us to to estimate the bonus rates and the payment by result rates. That means if a worker can meet this basic standard, minimum standard, then I can pay you the salary. If they perform higher than average level, I can give you more. Okay, reward you more. That's the situation that we need to set the benchmark for comparison. If you really want to make use of method study, then make use of work measurement techniques. It's very similar to method study, like record, examine, develop, install, and maintain. Just repeat these 5 major steps, like method study. Okay, you can make use of work measurement techniques as well. So by definition, work measurement is a kind of a process management. That means we try to make some measures on the production process numerically. Okay, try to find out the standard duration. Okay, so in terms of work measurement techniques, we have also 2, right? Continuous time study and activity sampling. For continuous time study, that means it will involve the measurement of the time taken to perform a particular task using a stopwatch. Okay, at the end of the day, we want to set the standard. That means how long we take for this activity to complete on average, a reasonable duration. We applied continuous time study. Activity sampling means we try to check out the work that we are carrying out according to the plan based on statistical method of sampling. Again, we are going to play around with statistics and try to assess a mechanism for quality and utilization. For example, whether machinery or worker is working versus idling. We may want to find out the percentage between them. Okay, what's percentage of actual working and what's percentage of lazy idling for your resources. Okay, if you want to, okay, let's talk about continuous time study. There are some basic features that you need to know under time study. In fact, I just extract some information from some of the previous journal paper written by me. This Chen is me, and Kuasrami is my PhD supervisor. Now already retired 3 years ago. He's now back in Sri Lanka. We published a paper to make use of continuous time study and this sampling. Okay, so for details, you can refer to this Chen and Kuasrami journal paper published in 1995. Okay, just over 30 years ago. Okay, continuous time study. Again, it will be more suitable for those activities with a cyclic nature, with a few resources involved, just like the 4 cycle times. Again, if we can focus our attention to those repetitive activities, the impact or effect will be very significant. And we try to do some measurements from start time to finish time of a certain activities. And we try to use a stopwatch to measure time taken for each sub-activities by using some standard data sheet for record. And then from the 2 consecutive readings from the stopwatch, we can find out the durations for each of these activities for record. In order to achieve a high reliable results, okay, we may need to make adequate number of site observations ourselves. Those are the key features about continuous time study. Okay, so in real life, there are a lot of productivity measurement indicators that we can think of, depending on which level. It may be macro level, meso level, or micro level. Okay, for the macro level, usually senior management or top management, that means your boss, the CEO, the MD, may be more interested. Okay, maybe they are just interested in the meso and macro level indicators, just like a meter square or floor area per man day. Okay, that means per man day, how many meters square or floor area can be completed. It's more a general measure holistically as a whole. Okay, middle level maybe at the middle management. Okay, just like project manager. How many meters square moving can be completed per man day? Macro level may be more on related to the supervisory staff or the frontline site workers, depending on the trade. For example, how many meter cube of concrete can be cast per man hour, or how many meter cube of concrete can be pumped by the concrete pump per pump hours, okay? Or how many man hour will be required in order to cast 1 meter cube of concrete, formwork or steel, okay? So with that, at different levels of personnel, we may have different measures of productivity indicators. Okay, so in order to illustrate the concept better, I try to use some examples, real-life examples for better illustration. This also formed part of my PhD study at HKU some time ago. Okay, so this is the case study of a Hong Kong UU medical complex. Now 就係香港大學李嘉誠醫學院。Okay, there's a new medical complex there, and I try to use this project as a case study to see how to apply those method study work measurements to analyze the different operations, and in order to get some statistical data. For example, we want to look at the column concreting operation. That means we try to pour in some concrete inside the column formwork. Okay, so first of all, we need to record some of the basic information about the operation. For example, the maximum volume of truck mixer in mixer drum in truck mixer， 填攞車嗰個石屎斗個容量。Okay, usually 7 meter cube. Actual volume of concrete in the mixer drum, usually 6 meter cube, or not fully loaded. What's the volume of skip bucket？ 一個石屎斗平均裝嗰啲石屎咧 ，for example 1.2 meter cube. Horizontal distance from tower crane to truck mixer, maybe 25 meter. Horizontal distance from tower crane to pacing location, 15 meters. Working floor level, maybe we start from ground level. The concreting gang, maybe 4 concreters, 4個石屎師傅工人 working together. Okay. Sample size of concreting cycle. Maybe we just want to look at 10 concreting cycles to make observations. Of course, the more the better. And the structural element to be under investigation is a column. The dimension like this. Number of tower crane used, 1 tower crane only. Number of skip bucket used, only 1. Then we are interested to find out what's the average cycle time to cast the concrete from the truck mixer to the column formwork. How to find out this value? 7 minutes and 40 seconds. If we can know the average cycle time, then we can find out the concrete pacing rate, or called the productivity rate, unit rate. Okay. For example, we have the number of concrete, 1.2 meter cube, divided by the time for 1 concrete cycle. We can get the value 9.39 meter cube per hour. Okay, that means for 1 hour, we can cast 9.4 meter cube of concrete by using the tower crane and skip bucket method. This forms a unit rate measure. Suppose you have 100 meter cube of concrete to be cast. Then by simple calculation, 9.39 multiplied by 100 meter cube, you may estimate how long to complete the whole concreting process. So this average cycle time and the concrete pacing rate is very useful for estimating purpose. Okay, so how to get all these values? Now suppose we are now looking at the concreting cycle times. Okay, concreting cycle times. First of all, we look at this. This is your operation. Then you may need to break down this operation, concreting cycle times, into some kind of sub-activities, okay, in order to measure the individual durations. For typical concrete cycle times, we can break it down into at least 6 major activities shown here. For example, we may discharge concrete from chop mixer 田螺車 to skip bucket, and then lift up the skip bucket and swing to the pacing location, lower skip bucket position to discharge, open bucket and pour out the concrete inside the column formwork. After that, you can lift up the empty bucket and swing back to your original location. That means the chop mixer. Finally, the tower crane will lower down the empty bucket and position in order to receive the next pour of concrete from the chop mixer. Now you can make use of your stopwatch, okay, just to count, okay. Maybe you start at 0 minute 0 second, start your stopwatch, and then you can measure how long will it take for activity 1, discharge concrete from chop mixer into skip bucket. Maybe after 1 minute 7 seconds, you stop. That means it will take 1 minute 7 seconds to complete activity 1. And then you can restart your stopwatch to measure the start time and finish time for the second activity. Maybe another 58 seconds, etc. Okay. Then you can measure the durations of all these 6 activities under concreting cycle. So add up all these individual durations together, then you can find out the total concreting cycle time is 8 minutes 15 seconds. This is only for cycle number 3. If you want to have a more reliable results, you may need to repeat the process 10 times, for example, like this, okay? Now suppose I've collected 10 cycle times from 1 up to 10, and the duration for each of these activities 1 by 1. Then at the end of the table, I can add up all the individual durations. Add them up. The first cycle is 8 minutes 25 seconds, and the second one is 6 minutes 80 seconds, and the third cycle is 8 minutes 50 seconds, etc. Then I can add up all these 10 cycle times divided by 10 cycles. I can get the average cycle time should be 7 minutes 40 seconds. 7 minutes 40 seconds is the average value for implementation and reference. Okay, so the average cycle time is 7 minutes 40 seconds. The volume 1.2 meter cube divided by the time for one cycle. We can get 9.4 meter cube per hour if the concrete to be cast by tower crane and skip bucket method. Okay, how about situation for slat and beam? We can also use the same method, but this time instead of column formwork, we try to pour the concrete to slat and beam. And the average floor cycle time for slat and beam may be much shorter. Okay, imagine because when we are casting the slat and beam, okay, usually larger floor area, so that the time to pour the concrete will be lower, will be shorter. Okay, maybe only 4 minutes 30 seconds. For the same volume of concrete, 1.2 meter cube of skip bucket divided by 4 minutes 30 seconds, the yield rate is a bit higher, 16 meter cube per hour, a bit faster than that for formwork, equal to 9.4 meter cube per hour. It's quite reasonable, right? Okay, so before going on, I would like to give the short break for 5 minutes, and then we can continue with the sharing at 8:05. Okay, take a 5 minutes break first. Okay, take a short break. Okay, can you follow me so far for the lecture materials? Okay, very good. Thank you for responses. Just take a short break. Okay, dear student, can you hear me now? Okay, thank you. Let's continue with the rest of the lecture topic tonight. Okay, so before carrying on, I would like to show you some video, okay, regarding the complete cycle time. Um, Okay, so, the complete cycle times can be divided into 6 major activities, as I just mentioned. Uh, do, while doing while doing the making the site observations, I try to capture the video as well, so that we can know more about the operation. The first activities. Okay, the first activity is we try to discharge the concrete from the chalk mixer to the skip bucket here, right? The first activity. And then we try to capture activities by using video for future reference. Can you see all these videos? Can you see the video? No? Um, okay, no. Uh, screen. Can you see now the video? Oh no. Okay. Show the video. OK，睇唔到嘅，微博 share 個 file。Can you see the video now? Okay, very good. Okay, just look at the video. No sound. Yes, it's no sound. Just the video without any sound. OK， 咁啊，淨係片嘅啫，冇聲嘅。OK，see once more. OK，how about second activity? Or maybe you can look at all the activities together. Can you see the video now? Can you see the video now? Oh, thank you for your reminder. Okay, so that you can see the video now. First of all, we need to discharge the concrete from the chop mixer to the skip bucket, and the tower crane will lift up the skip bucket and swing to the location where the concrete will be poured out. That means the column formwork. While we are taking the video, we may also need to use your stopwatch to take the time required. Now, the tile crane will lower down the skid bucket, and the concreter is ready. Concreters are ready to position the empty skid bucket, and then try to position, fix it, and then open the skid bucket to pour the concrete out. You can see that the concreters are using the pocket vibrator to extract the air bubble trapped inside the concrete in order to prevent honeycombing problems. Okay, finally, the tile crane lift up the empty bucket and swing back to the truck mixer position. Finally, the tile crane lower down the empty skid bucket, and the rock is ready to position it in order to receive the next pour. Okay, because of this video is captured and maybe through the Blackboard website, there may be some time difference. Okay, anyway, you can have idea how to capture the video and measure the time duration for a typical concreting cycle. Okay, going back to our PowerPoint. Okay, let's continue with the discussion on this one. Okay, let's look at some other situation of time study. Now, for example, we try to use two different concrete pacing methods by using time study method. Again, based on my PhD research study. The two concrete pacing method is pumping method, to pump concrete to cast the beam and slab. Okay, usually for beam and slab, we have a larger floor area. We can use the concrete pump to pump the concrete faster. Okay, but for column and wall, usually we need to use the tile crane and skid bucket method, because the area of the column and the wall formwork is very, very small. Okay, we need to use the skid bucket to slowly pour out the concrete inside the formwork in order to make up the whole column and wall. Then we can carry out some site observations. For example, at the site level, we are trying to collect 10 pump pours and 10 skid pours. Okay, skid bucket methods. And total, we have collected data of 20 concrete pours on this case study project, and try to record the maximum concrete pump capacity is 40 meter cube per hour, and the skid bucket capacity is 0.8 meter cube, and the truck mixer capacity is 7 meter cube. Then here, right, what is the average daily pour size? Okay, maybe you collect the data over a week. Then on the day, what is the average daily concreting size to be cast? Okay, by using pump concreting methods, because we can pump the concrete faster, so that the volume to be cast per day will also be higher. In this case, it's 157.2 meter cube, and overall placing rates. Okay, that means how many after measuring the concrete cast per day divided by the total time taken to complete this concreting operation per day. Okay, then we can roughly get double 2 meter cube per hour as the overall placing rate. Concreting crew, it depends on how many concreters do we do. In this case, we may have 10 concreters. 22 meter cube per hour divided by 10 workers. We can get 2.2 meter cube per man hour. How about the plant? Depend on the pump or crane. In case of pump, then for this volume of concrete, what's the time taken by the concrete pump to pump this amount of concrete? This amount of concrete divided by the pump durations, you will get 20.7 meter cube per pump hour. How about truck mixer? Okay, volume of concrete divided by the truck mixer hours staying on site to complete the whole concreting process. Maybe the result is 12.8 meter cube per truck mixer hour. How about crane and skip bucket method? In this one, because the crane and skip, the time required may be longer, so that the volume of concrete to be cast per day may be much smaller. Okay, maybe only 48.6 meter cube, and overall placing rate, volume of concrete divided by the duration to finish this concreting operation by using this method, maybe 11.3 meter cube per hour. Concreting crew, maybe 9 or 10 workers. That means 1.2 meter cube per man hour, 10.8 meter cube per crane hour, and 9.7 meter cube per truck mixer hour. Okay, so based on our site observations and simple calculations, we find out that average concrete placing rate by pump is almost double up than that by crane and skip bucket method. Okay, by using concrete pump to pump the concrete should be faster, much faster than the method using crane and skip. Another scenario is how about the time spent by truck mixer at site level. Again, by using the same method, pump, beam, and slab with distribution pie knives, and cast the column and wall using skip bucket method and tower crane. Then we can measure the average time on site for pump concrete and skip bucket. For using concrete pump, because the concrete from truck mixer will pump much faster to empty, okay? So the time required will be shorter. But for skip bucket, it should be longer, okay? Average time for unloading or discharging concrete. This one only take 15 minutes. Skip method around 26 minutes. So the average percentage time for unloading, that means 15 minutes divided by 24.5 minutes. The percentage around 61.2%. For skipped method, 75.9 minutes divided by 42.9 minutes is around 60.4%. Okay, we try to make some site observations, 10 observations each for each placing method in order to get more reliable results. So what we can observe here, although the unloading time is quite different between these two methods, but the average time for unloading concrete almost similar, around 61 to 60%. Apart from concreting operation, we can also apply the same method to measure the steel fixing rates measured in ton per man hour based on Hong Kong buildings using time study method. For example, we have a different size. Then we want to find out the unit rates to fix steel reinforcement to structural wall and slab. Okay, horizontally, we can take the average around 0.2, right? 0.2 ton of steel reinforcement can be fixed per man hour. Okay, for slab also around 0.2. Okay, by using this unit rate measure, suppose you have a 1,000 ton of steel reinforcement to be fixed, then how many man-hours will be required? By simple calculations, we can find out all these man-hours for site planning. We can see from this photo, the steel fixers are fixing the steel reinforcement to the column and slab. This steel fixer is fixing steel reinforcement to a structural wall vertically. Slab is horizontally. Okay, another method is multiple activity charts. That means we try to use multiple activity charts. Try to put up all these activities on a single diagram and their time relationship between two or more resources. Usually, we will look at the workers, plant equipment, or materials. This method will be very useful if you want to look at the interactions between the workers, plant equipment, and material, which will be repeated in periodic cycles, just like the concrete cycle times. Okay. By using this multiple activity charts, it can help us to find out any bottlenecks or idling resources at your site, looking at the utilization profile of each resource in parallel bars. Okay, again, let's take the example of concrete cycle. Again, for a typical concrete cycle, it will consist of these 6 major activities and their corresponding duration. Then we can put up all this information, all these resources, and the duration on a multiple activity charts. Multiple activity, that means we try to put up all the major activities for their operation into a diagram for comparison. Horizontally, we can show the time bar, okay, 1 minute, 2 minutes, 3 minutes, etc. Vertically, we can show the site resources, chop mixer, in this case, right, chop mixer, tower crane and skip bucket, and also concrete crew. There may be 3 resources involved in this concrete operation. Okay, then we can look put down the time duration for each of this activity one by one. Let's look at the chop mixer. For the chop mixer, what's the first activity of concrete cycle? The first activity is discharge the first concrete from chop mixer into skip bucket. Okay, it may take 1 minute and a few seconds. Finish at D1. Then the chop mixer will become idling. Idling means doing nothing, just waiting. Okay, because after discharging concrete from chop mixer and skip bucket, the chop mixer has nothing to do until the return of the empty skip bucket. Okay, so the idling time for chop mixer. How about tower crane and skip bucket? Okay, then we carry out follow the 6 major activity 1, 2, 3, 4, 5, 6, and then finish one cycle. It may take 8 minutes, 15 seconds, and then repeat 1, 2, 3, 4, etc. How about the concreting crew? At the first concreting cycle, okay, the concrete crew has nothing to do. So for the first 3 activities, they are idling. They are just waiting for the skip bucket to come. Okay, starting from activity 4. What is activity 4? Open bucket and pour out concrete, because the concrete crew need to position the skip bucket ready for pouring out the concrete inside. Okay, so they need some time to do the pour out the concrete into the column formwork and try to make use of the pocket vibrator to expel the air trapped inside the concrete in order to prevent honeycombing problems. It may take some time. After finishing compacting concrete, the concrete crew becomes idling again until they receive the second skip bucket ready to be poured out like this. So all this activity will be repeated many times depending on the situation. Now, okay, we may have 2 situations, scenario A and scenario B. What does it mean? Okay, by looking at this multiple activity charts, we find out that the idling time of the chop mixer can only be reduced by reducing the cycle time. Very obvious, OK？ 如果 cycle time 短啲，咁呢個 idling time of chop mixer 都會短啲。OK？ The first observations that you can draw. The second one is, what is scenario A? Scenario A means the tower crane and bucket become idling. What happened there? Okay, look at immersion. Under scenario A, the tower crane and skip bucket is idling. That means they may be waiting for the concrete crew to do the compacting work. Okay, the tower crane and the bucket may hoist. The tower crane may hoist the skip bucket in the air until the concrete crew finish compacting the concrete for the previous pour, so that the tower crane and bucket become idling. In this case, they're just waiting. Okay. How about second scenario? Second scenario is the concrete crew becomes idling. Maybe they finish compacting the concrete, but the next skip bucket is not yet arrived, so they become idling. We may have these two situations. What can we do in order to sort out scenario A and scenario B? Okay, in order to reduce the idling time for scenario A, we can increase the number of pocket vibrators. Okay, because if by having more pocket vibrators, then the compacting concrete activity can be finished earlier, so that the idling time can be reduced here. The second scenario, we can either decrease the skip bucket, okay, by decreasing the volume skip bucket, so that the worker can finish compacting concrete earlier, and then they become less idling. Or we can use two skip bucket. Okay, but use two skip bucket. While the first bucket is transferring to a column form work, then the concreter can pour the concrete into the second skip bucket from the chop mixer in order to reduce the time involved. So by using multiple activity charts, it can help us to find out the problems there and then try to make some remedial actions for improvement like this. Okay. Apart from those unit rates measurements, we can also have some other indicators like speed indicator of construction. Okay, depending on the different types of buildings, we can roughly, on average, find out the average speed of construction. Okay, suppose you have collected data over 100 public housing, and the speed of construction is defined as the total GFA in meters square divided by consumed period in weeks. Suppose you have collected the data, the ratio of this, the speed of construction data over 100 public housing projects. Add them up, divided by 100 projects. You will roughly get maybe 277 meters square per week. Public non-residential, private commercial, private residential, by developing this speed of indicator. Now suppose you have 100,000 meters square to be done. Then how long will it take for the construction duration? You can make use of this unit rate productivity measure multiplied by the GFA area, and then you can roughly get the duration required for the projects. Okay, apart from continuous time study, we can also have active sampling or wet sampling methods. Again, what is active sampling? Active sampling is a technique in which we can make a number of successive observations over a period of time of a group of machinery, process, or workers, and try to observe and record what's happening at that instant. And the percentage observation record for some activities is a measure of the percentage that the activity or delay will occur. A very comprehensive definition. In order to carry out activity sampling, we may need a large number of instantaneous observations, usually made at fixed intervals, maybe at 30-second interval or at random time slot. Okay, that means after 30-second interval, you make an observation to that object to see what happened, what it's doing. After another 30 minutes, we look at the same resource again to see what it's doing. Okay, productive or non-productive. In order to collect a large amount of data, we may need to develop some kind of standard data sheets to help us to collect all this data correctly and systematically. Again, in order to have a more reliable results, we may need to have a sufficient number of observations to be made. Okay, statistically, we can make use of this equation. How many site observations do we need? Capital N is the total number of site observations required, that means the sample size. And capital P is the basic productivity level. Usually we assume it's 1/2 of the time is doing something productive. We're usually 1/2. And L is the absolute limit of error, usually plus or minus 50%, equal to the confidence interval. Confidence level equal to 95%. If we insert all this value, 4 times 50, 100 minus 50 divided by 5 squared, that means we need to have, around at least 400 site observations in order to get the more reliable results. So at site level, we may have a lot of examples of using active sampling. Okay, for example, we want to measure the utilization levels of tower crane at site level, truck mixer activities, as well as worker efficiency of different site workers, like concreters, timber former erectors, as well as steel reinforcement fixers. Again, let us look at this case study again. Okay, another case study, another campus building located at HKU near Hacking One building. Again, we try to make use of all these parameters into the equation, and we need to have at least 400 site observations in order to get more reliable results, and try to make the observation fixed at 30-second intervals. Well, let's see how we can do it. So in order to collect the data, we may need to compile a standard data collection form like this. Okay, on top of the form, you may write down some personal details about the project. Okay, project name, the date of collection, time start, time finish. At the lower half of the form, you may record the time. Okay, maybe you start the site observation at 9 a.m. sharp, and then on the far right hand side, you can list out, okay, whether a tower crane is hoisting the formwork, steel reinforcement, concrete, or other materials. If they are hoisting those materials, we can regard the tower crane is doing something productive. Okay. If the tower crane is just moving empty or just idling, stop there without hoisting anything, then we can regard it as doing something non-productive. Okay. Now suppose I start the site observation at 9 a.m. sharp and then look at the tower crane. What is it hoisting at that moment? Maybe this time the tower crane is hoisting formwork. So under formwork, I put a tick here. After 30 seconds later, this time I look at the tower crane again. The tower crane now is hoisting the steel reinforcement. So I put a tick here. After another 30-second interval, that means 9 a.m. 1 minute. Now the tower crane is hoisting the concrete. I put a tick here. You may continue with the observation until you get 400 observations. At the end of the table, you can count your fingers how many ticks under formwork, how many ticks under reinforcement, how many ticks under concrete, how many ticks under moving empty and idling. Maybe at the end of the day, you find out that over 3 working days, you find a total number of ticks here, right? Add up all these numbers is 254, non-productive 154 ticks. Then you can roughly estimate out of this around 400 observations, 254 divided by total number of observations, you can get the percentage 62.3. Okay, moving empty 71.70%, idling around 20%. And the crane utilization level is defined as the time spent by the crane working, doing something productive, divided by total time the crane is available for work, multiplied by 100%. Okay, by looking at this figure, 62.3%, that the tower crane is hoisting material, the site engineer or the planning engineer may think that whether is acceptable or not, because the tower crane is only around 62% productive, hoisting material on a typical day. Okay, and there are quite a high percentage of time moving empty or even idling, up to 20%, so that the site engineer can think whether we can make the tower crane more productive in hoisting material by increasing that percentage. Okay, how about second example, this activity profile of chop mixer on site? Okay, usually the chop mixer will do all these activities: unloading or discharging concrete, curing, washing, and idling means unloaded. Again, by using the activity sampling method, we can put the text what the chop mixer is doing at a particular moment: unloading, curing, washing, or idling, and then add up the total number of ticks and find out these percentages for reference. So here we find that the chop mixer usually is around 62.5% that is discharging concrete, but the curing time is up to 11%, idling up to 20%. Again, we need to find out the reason why the chop mixer always idling and sometimes curing. Okay, if we can find out all this problem, we can fully utilize the chop mixer time on site, okay, in order to make it more productive. Okay, and another situation is we want to look at the working efficiency of different site workers using activity sampling methods. Okay, before carrying out the site observation, we may need to classify the site workers' activity into 3 types. Direct work, that means it will positively influence the progress of the activity, group under item A. Essential contributory work, that means those work, although indirect, but have a positive influence on the progress, such as carrying materials or tools, making some work-related communication or measurements, item B to E in the next table. Finally, type C is ineffective activities, including doing nothing or doing something which is not important to the progress. For example, just waiting for material, tools, item F to M. Okay, now suppose we want to look at the situation for the 4 types of common workers, like formatting crew, bar bending crew, bar fixing crew, and concreting crew. Okay, suppose let's look at the example of formwork crew on the building site. Okay, again, first of all, we look at the formwork crew. The formwork crew may consist of the foreman as the leader. Under him, there may be 2 formwork crew, crew 1 and crew 2. Now, similar to the case of tower crane, at 9 AM sharp, I try to make the same observation to these 3 workers. Look at the foreman, crew 1 and crew 2 at roughly at the same time. and then to see which type of activity that the foreman is doing. Maybe he's doing something on Cat 1, direct work, Cat 1, Cat 2, and Cat 3. If he's doing something on direct work, then you may just put down a tick here. Okay? If they're doing something on Crew 2, he's maybe doing something under Cat 2. Okay? Contributory. For Crew 2, he's maybe doing something unproductive, okay, non-productive. Then we just put a tick under Cat C, like this. Then after another 30 interval later, we look at the same crew again. What's the foreman is doing? Cat 1, Cat 2, or Cat 3, etc. Okay? We try to make the observation consecutively over 400 observations, and then count the total number of ticks. 1 means direct work, Cat 1. Cat 2 means essential contributory work, and Cat 3 is ineffective activities, non-productive. Okay, you find, suppose we repeat the same exercise for the 4 types of workers. Then finally, you can get all this percentage here, right? Former crew, bar bending crew, bar fixing crew, and common crew here. Direct work, item A, B to E, essential contributory work, F to M, ineffective activities, and the corresponding percentage shown here. Okay, after looking at the percentage, you may make some side observations. For example, among the 4 types of worker, the bar fixing crew has a high percentage of direct work, up to 40%. But the lowest one is bar bending, so that we need to focus why the direct work of bar bending crew is so low, just 11%. Okay, another observation is like the bar bending crew and the counting crew in blue color. Okay, you find the bar bending crew always carrying tools and material within the work area. Okay, for bar bending crew, 即係北鐵嘅師傅。Okay, usually they will carry out the take out and take up the steel reinforcement and bend to suitable position or cut it down into small pieces. So most of the observation, they are doing activity in activity B like this. Similar to concreting crew, okay, they always carry pocket ribators and also concrete to do the concreting work, so that the percentage of carrying tools and material in these 2 workers categories is very high. How about another one, measuring and other minor contributory work here, right? For former crew and bar bending crew is quite high, okay? Forwarding crew up to 80%. For forwarding crew, they usually use the ruler and saw in order to cut the timber formwork into suitable sizes for fixing, okay? So it's quite reasonable to look at, to find that quite a number of the time, they are doing some measurement work for formwork crew and also bar bending crew. Okay, finally, another observation may be related to common crew, waiting for tools and material, wow, up to 29, almost 30%. It's not too productive. So the site engineer may need to find out why the counting crew always waiting for tools and material. Maybe they're just waiting for a skip bucket to come to the site, okay? Then they need to find out why they're always waiting. Is there any problem between the concrete delivery from the batching plant to the site level? Okay, by collecting all this data, it can tell you a lot of secrets behind, and then identify the problems and make some improvements. Okay, after collecting the data, apart from presenting paper, the data in the table, you may also make use of some graphical method, okay, to show the distribution clearly by using diagrams and tables here. Okay, after sharing with you some of the basic concepts regarding continued time study as well as this template, now let's conclude. If you want to increase all the major factors which will affect labor productivity in construction in general, okay, based on literature. For example, the skill level, number, and labor force. If the skill level of labor can be enhanced, productivity will also be higher. Very logical, okay? Age and physical health condition of workers. Okay, if they are younger, they should be more productive. Okay, motivation towards labor force. We can provide more financial incentive to them in order to encourage them, motivate them to work faster and harder, just like year-end bonus, cash reward, prize award, or job promotion. We can also consider the degree of mechanization and level of utilization. If we can use more mechanized method of construction, like tower crane, large panel steel forming system, hydraulic concrete boom, pacer, convection plant on site, then we can also increase our productivity. And we try to maintain the continuous workflow without any interruption by smooth supply of material, plant and manpower, performance of contractors, availability of materials and reduced variations. All this can help to achieve faster and higher productivity. Project complexity, okay? That means the buildability of project design, okay? If your project is so complex, it may take longer. Require quality of finished work. Higher quality require more time to do, okay? Also depends on the construction methods. If we can use more standardized design construction sequences, just like public housing project, or we can make use of steelwork construction versus reinforced concrete. More recently, CIC is highly encouraged using prefabricated modular flat units, 組合屋或者個貨櫃屋, okay? Just put on top, pre-finish the flat, and then put up one by one in order to speed up the construction process. Or whether we can use more project managers to look after the overall site supervision in these areas. Finally, how about increment the weather condition? Okay, if the weather is so unfavorable, especially during the hot weather of over 35 degrees Celsius in summertime, heavy windstorm, typhoon signal number 8 hoisted, then the site work will be suspended, okay, and your productivity of the site will be affected. Some other researchers also found similar factors which will affect the labor productivity in construction, just like material availability, whether we get the material on time, okay, tools availability, work be done, whether you can finish the work right for the first time rather than rework, whether your site is overcrowded or small, is there any delays in the work inspection by the government or engineers, crew interference, a lot of turnover absentees from the workers, or a lot of changes from the foreman. All these will affect your productivity and progress. Well, last but not least, how about those essential factors discovered from Singapore, okay, especially? Similarly, you have availability of project design, structure of industry, whether we can use more skilled labor versus unskilled labor. If we can make use of more skilled labor, the productivity will also be higher. Whether we can provide more training to the labor in order to enhance their skills, whether we can use more mechanized method of construction and more automated methods, use more foreign worker who are familiar with different types of construction methods, standardization of your building design, or mandatory adoption of prefabricated elements under the building authority, all this. Okay, almost finished the lecture tonight. Okay, I shared with you some basic concepts regarding productivity, including production, productivity, and productivity techniques, including the work study. Under work study, we have a method study, try to look at the whole production process step by step, and also make use of work measurement techniques, including continuous time study, to estimate the standard duration as well as active sampling or work sampling. Try to estimate how productive your worker or your plant will be. Last but not least, I share with you some of the those essential factors which will affect the productivity. Okay, if you put more focus on those key factors, your productivity will be enhanced in the end. Okay, if you want to look for more detail about the reference cite in this PowerPoint, you are welcome to refer to all these suggested references at your own time. Okay, any problems on this topic, construction productivity measurement? Okay, any problems so far on this topic? Okay, if no, finally, I want to briefly show you the let me see, the lecture tutorial schedule. Yes, this one. Okay, I make a bit larger. Okay, so this the lecture tutorial schedule for part-time student like you, right? In this schedule, okay, I myself together with NU will be responsible for different lectures, and the tutorial will be delivered by 2 subject tutors. Okay, if you go look down. Okay, so tonight is 13th of February. I've finished sharing with the subject introduction and a topic on construction productivity. Okay, tonight. Next week, same time, the subject tutor, Dr. Amos Dacko, okay, from Ghana, like Africa, okay, will take over the tutorial on my behalf. Okay, so Dr. Amos Dacko will be with you on the tutorial starting from next week. He will give you a seminar presentation briefing as well as the assignment in-class tutorial exercise on construction productivity with you. Okay, so you will see Dr. Amos Dacko in the next week tutorial. After that, I will come back to share with you another 2 lecture topics on decision theory and inventory control theory 2 weeks later. Okay, and then followed by the tutorial and in-class exercise in the tutorial class, and then my lecture on Monte Carlo simulation, and then the in-class exercise by the tutor. After that, according to the university calendar, you have a 2 weeks recess period for your study, low lecture and tutorial class in these 2 weeks. After the recess period, I'm going to share with you the last topic on fast-track construction plus subject supervision under my lecture topics, followed by Q&A. Okay, and then we finish the first half of the lecture and tutorials like this. After that, Dr. NU will take over the subject to share with you some other topics shown here, right? Like this pattern, like this schedule. And there's a holiday right here, Fatan, okay, on 30th of April. Again, a low lecture tutorial class in this week. For your oral presentation, I try to push at the end of this subject so that you can have more time for you to prepare for your presentation and your written reports. Okay, so in this class, it's around 31 students, 31 part-time students, 5 persons per group. Okay, 5 students per group altogether we should have 6 groups. 6 groups. So you may start thinking about I have already uploaded the seminar presentation questions to the Blackboard website. You can have a look there. One is on fast track construction, one is on risk management, the last one on value management. Okay, and I hope that 2 groups will choose fast track construction, another 2 groups will choose risk management, and the last 2 groups will choose value management. Okay, so that all the 3 topics will be chosen by 2 groups to make your presentation. Okay, just start thinking about your students in your group to form a group to do your presentation. Think about your presentation questions, and then submit your listing. Okay, group listing, and also your chosen topic to your tutor next week. Okay, is it clear? So every night we try to share 2 lecture topics with you during the lecture, so that you can have some time to digest in 1 week time. And then when you come to the tutorial, you've already digested the material that I deliver this week, so that you can do the in-class exercise in the following week, like this pattern. Okay, lecture, 2-hour, a 3-hour lecture, and then followed by 3-hour tutorial, like this pattern. Okay, I think it's better for a part-time student. You may need some time to digest material first in 1 week time, and then do the in-class exercise, if there's no objection to you. In fact, your part-time class will be the last resort. Okay, the last intake from our BLE department. Okay, you student this year will be the last batch of student on the part-time mode under our BLE. Okay, so after your graduation, BLE should have no part-time student at all. Okay, so it's your final intake in your case. Yeah. Oops. Can you see my PDF file here on lecture tutorial schedule? Oh no, sorry. Okay. Let me share our screen. Let me try again. Can you see now the lecture tutorial schedule here? Oh, okay. Sorry for that. Okay. So I just mentioned that you may just more or less follow this pattern, okay, in terms of lecture and tutorial schedule. Usually we try to share the lecture topics with you first in 1 lecture, and then followed by the corresponding tutorial exercise, so that you can have some time to digest the lecture material tonight in 1 week's time, and then work on the in-class exercise in the next week tutorial. Okay. So next week, Dr. Amos Ducko will be with you on the tutorial exercise, and then we'll come back and tutorial, etc. Okay, so think about the seminar presentation questions, and think about your grouping with your classmate to do your presentation. Okay, 1 topic, 2 groups, 1 topic, 2 groups, and 1 topic, 2 groups, like this. Okay, yes. Okay. So I almost finished the sharing tonight. Is there any problems to you? Is it clear to you? Can you follow me? Okay. I hope I will not go too fast. Okay, and you understand the concepts and the materials there. Okay, if no further problem, I would like to stop the lecture here and see you soon, okay, for my second lecture 2 weeks later. How to choose the presentation topic? Okay, you can think about the presentation topic right now together with your classmate, okay? Maybe you can have some internal discussion among yourself first. First of all, think about your grouping list. Okay, each group should consist of 5 students. 5 students. One group may have 6 students because altogether we have 31 students. 3 1 student. Okay, so 5 students per group. Think about your student grouping to do the work, and then choose the presentation questions. The presentation question already marked up to the Blackboard website there. You can go to the Blackboard website to have a look at the questions and then make up your decision which seminar question you want to choose for a presentation with your classmates. And next week, the subject tutor will discuss with you. Okay, so within the coming days, you can think about your student grouping and your chosen, your preferred seminar topics yourself first. Okay, there's also a form to write down your student name in your group and your chosen topic so that the tutor or myself can have a look. Okay, we hope you can sort out, okay, among yourself, okay, with your class web or classmates. Okay, 2 groups on fast track construction, 2 groups will choose risk management, and the rest 2 groups will choose value management. 2 plus 2 sub plus 2, something like that. Is it okay? Yeah. Okay. Okay. Is there anything you would like to ask here? Okay， 如果大家冇問題嘅話咧，I want to close the lecture tonight and hope you have a nice day and have a good sleep tonight. Thank you for attending and see you later. Bye bye.會㗎，嗰個lecture material 咧我會 upload 翻上去嗰個 lecture topic 下邊，咁大家可以再翻聽或者翻睇咁樣嘅，唔使擔心啊。